Hi everyone, my name is Bilal Khan and you are watching Simplified Coding. In this video, I will discuss a sample project that I have created using Jetpack Compose. In this project, you can learn using Firebase Firestore, Firebase Authentication, Dependency Injection, Repository Pattern, Jetpack Compose, MVVM architecture and many more things. So if you want the source code, then the link is given in the description of this video. But first, let's see the application. So this is my device and I will open the application in this device. So here you can see this is the application. So first, we have the authentication screen in this application. And recently, I published a tutorial that covers using Firebase authentication with MVVM architecture. And this is the same code from that tutorial. I will leave the link of that tutorial in the description of this video, so you can check that out. So first we have the authentication screen and first we will log in. So I will enter my email and then password and login. You can also sign up. There is an option to sign up as well. So this is the application and in the home screen we can see some informations. And if I open the navigation drawer, then we have some options to navigate in the application. So let's open invoices because this application is to create invoices. So you can see I have created an invoice. If I click on this invoice, I can see the details and I can go back. I can edit the invoice, delete the invoice, and I can mark the invoice as paid. To create an invoice, I can click on this button, that is the plus button. And here I will select a business, I will select customer and then tax and then add my invoice items and then I can create an invoice. I can add customers from this menu, I can add businesses from this menu, and from here I can add taxes. And in the dashboard I can see all the informations, for example total number of invoices, total number of received amounts, etc. So this is the sample project that I have created and the UI is completely built using Jetpack Compose. So now let's discuss the source code of this project. So this is my Android project. And first, let's start with the dependencies that I am using for this project. So first, I will open the app level build.gradle file and here you can see we have added many dependencies. So first one is the Kotlin coroutines that I am using for this project. Then I'm using Firebase and from Firebase I am using authentication for my login and sign up screen. And then I'm using Firestore, that is from Firebase, and it is a NoSQL database. And I'm using Firestore database for storing data of my application. Then I am using Compose things. So these are the Jetpack Compose things because the UI is completely built using Jetpack Compose. And for navigating between different screens of the application, I am using Jetpack Compose navigation. I am also using Compose constraint layout, and for the dependency injection I am using Helt. So this is Helt and this is Helt compiler, and then I am also using window insets, and I am using window insets to scroll the screen up when the keyboard is visible for a good user experience. So I am using all these dependencies. Now let's try to understand the code of the project. So when you launch the application, you see the login screen. You can also sign up if you are not already registered. For the authentication, I'm using Firebase authentication and it is the same project of the last tutorial that I published. I will leave the link of that tutorial in the description of this video so that you can watch that video as well. Now after authentication, we have our application where we create invoices. And to create and store invoices, I'm using Firestore database to store data. Firestore is a NoSQL database where we can create document and collections. You can visit official Firestore documentation to read more about it. So basically, we can create data classes to store information in Firestore database. So we need entities for this project because Firestore is a NoSQL database and we create collections inside it, and every collection can have multiple documents. For now, let's consider a document as a data class. So we need to find out what data classes are required to save information to Firestore as per our project's requirement. So in my case, or in this application's case, I have 6 model classes. So if you open the data package, you can see I have one more package here, that is models. So here I have my 6 models: business, customer, dashboard, invoice, invoice item, and tax. Now for every data or model class, I have some common properties, and that is why I have created an abstract class that is called base model. So you can see I have an abstract class base model and it has 3 properties: ID, created at, and updated at. And because I need these 3 values for every model class, whenever I will create a model for my project, I will extend base model. For example, if I open business class, then you can see I am inheriting base model for creating this data class business. And the same I am doing for customer, dashboard, invoice, invoice item, and tax. So the rule of this project is whenever I want to define a model class, it should inherit base model. And this way, I do not need to define these 3 properties, and these are ID, created at, and updated at. So I do not need to define these 3 properties again and again and again in every model class. One more thing that you should note is here you can see I have defined default values for all the vals. And it is important because with Firestore we have to have an empty constructor, or else it will throw an error while retrieving the objects from Firestore. And that is why I have defined the default values for all the vals so that we will have an empty constructor to initialize this business or any data class. Now whenever we perform any operation with our model, we can have success, failure, or loading. And to wrap these 3 states, I have defined a sealed class called resource, as you can see here. The class is pretty simple and it is a generic class that we can use to wrap any data class or any class. Now this project is divided between 2 layers. The first one is the data layer and the next one is the UI layer. You can see I have data package and this is my data layer. And to operate on data, I have created repositories. And for every entity or model class, I have a separate repository. So if I open this home, you can see I have repositories for every single entity. And because I have some common functions for every repository, I have created another base class that is base repository. So you can see we have a base repository here. So let's open this class. As you can see, this is again a generic class, and for the implementation of this class, we need to define the type of the model class. And the type can be any model class because all the models in our project are inheriting this base model class. And that is why I have defined the type T as base model. Then we are passing Firebase auth object, Firestore object, and the database node string. Every repository will fetch data from Firestore. So I have a common getData function that will return the list of model type. So here you can see the return type is list of type T. That means when we will define the implementation of this base repository and we will define the actual model class, we will get the list of that model class. And here you can see we are getting the data from the query snapshot that we get from Firestore, and we are converting the snapshot to the model that is defined. And we are setting the model ID and created at and updated at, because these three values are common for every model. So we can simply use this function to get list of model from our Firestore. And we do not need to define this function in every repository because it is inside our base repository. Now let's see our repository implementation. Now let's open our repository. For example, I have customers repository here. So for every repository, first I have defined an interface. And inside the interface, I have all the functions that are required for this repository. And then I have the implementation of the repository, as you can see here. And I am inheriting the base repository. I am defining the model class type, and I am passing the auth, Firestore, and the database node. It is a string, you can see here. So to store customers, I have created a node inside Firestore, and inside this node I will store all the customers for a particular user. And the same way I have defined all the repositories required for this project. So you can see we have invoice repository, we have my businesses repository, we have tax repository. So in all the repositories, we have the basic CRUD operations that are creating the value inside Firestore database, getting the values back from the database, updating the existing value, and deleting the value in the database. Now to get all the repositories, I have created this DI package, and inside this DI package, we have our application module, and this app module will provide all the dependencies that are required for this project. And I am using Hilt for the dependency injection here. Now in my project, I have two activities. One is the authentication activity. So if I go to UI, you can see I have auth, and here I have authentication activity. I will close all the other tabs, and here I have my authentication nav host. And when the authentication is successful, we go to the home, and here we have home activity where we have the home navigation host. Now you may ask why I have created two different activities, and the reason is I needed two different nav hosts. Because in one nav host, I need to create the navigation drawer, and I do not need the navigation drawer in my authentication screen. So if you go to home activity and if you open this home nav host, you can see we create the navigation host like this. So in my home nav host, I have this model navigation drawer. And for the content of the navigation drawer, we have the top bar that is common for all the screens. And then again, we have content for this top bar. And inside the content, we are defining a nav host. And because I do not want this model navigation drawer and this top bar for my authentication screen, I created a different activity for the authentication. We can do the same thing with single activity as well, but personally, I found making two separate activities more convenient. And because we have two activities in this project, I have created a base activity for the common things that I want inside the activity. So here you can see we have the base activity. And inside base activity, I am just setting this set on apply window in sets listener, and I am doing this to scroll my content up when the keyboard is visible. Now inside UI, we have all the packages, for example, customers, dashboard, invoices, my businesses, navigation, and taxes. In this video, I will not discuss a lot about creating composable functions for the UI because I already have a dedicated course about Jetpack Compose. So you can check that course. The link of the playlist is given in the description of this video. So what I would like to discuss is creating nested navigation with Jetpack Compose. So for this project, in the home screen, I have a lot of destinations. And when we have many destinations in the application, it is important to organize the destinations properly. So I grouped the common destinations as you can see here. So if I open my home nav host, so this is the home nav host, and here you can see inside nav host I have a composable because for the dashboard screen I have only a single composable, but for invoice, tax, business nav and customer nav I have multiple composables. So I have grouped these composables. So if I open invoice nav, you can see I am using this function, that is navigation, and inside this navigation I have many composable, and inside this navigation I have another navigation, it also has many composables. So I grouped all the required composables inside this invoice navigation. And it is very important when you have multiple screens in your application. So when we click the invoice option, we can create an invoice, we can see all the invoices, we can edit or delete invoice. So all these screens are here that are related to invoice. Then we have tax navigation, that means when we want to add a new tax or edit an existing tax, we have these two composables for that thing. So this is how you can create nested navigation graphs, and it is very convenient to organize all the composables in our navigation graph. Now another important thing that I wanted to tell you is how to share the same instance of a view model among multiple navigation destinations. For example, if I open the home nav host again, then I want to share only a single instance of the view model for this invoice navigation, so that I can easily share the data between all the destinations. And to do this, I have created a view model utils. So here inside the utils package, we have view model utils. And here we have two functions. So first, I am getting the navigation parent, and then we have the parent entry here. And now whenever we will create the view model using this function health view model, we will pass the parent entry. And now the same instance of health view model will be shared among all the child of this parent. So I am using this get view model instance function to create my view model. So if I go to invoice nav, here you can see I am using this get view model instance function to create the view model, and this is how I am sharing the same instance of view model among all the composables. And one problem I faced while building this project is while generating compose previews. So if I open the home nav host, you can see we have the home nav host here, and because I am using this health view model here, if I split it and let's say we want to see the preview, you can see we don't have any preview here. So the problem is, if you click on this option, you can see the problem is failed to instantiate a view model. So the problem is health view model function is not able to generate the instance of view model for compose previews. So if I open any other composable function, let's say I open manage customer, and here we need to pass view model to preview this manage customer. As you can see the preview here. So if I use health view model to pass the view model, then the preview will not be generated. But what I am doing here is I am creating my view model manually. So if you go to the preview function, then here you can see I have a fake view model provider, and from this fake view model provider I am calling the function provide customers view model, and this function is giving a fake view model, and then the preview is generating. So right now the Helt view model function and Jetpack Compose previews are not compatible, and that is why I have defined this fake view model provider object, and inside this object I have defined all the functions that will return fake view models. And because I am using interfaces for my repository, I can define fake implementations of my repository, and inside the implementation I am doing nothing because it is just for preview. So here I have implementations or fake implementations of all the repositories, and I am using all these repositories to instantiate my view model classes, as you can see here. And this is how I am able to generate the previews, as you can see here. So it is working absolutely fine. So that is all for this video, friends. I hope you found this video helpful and learned something. In case you have any question regarding this project, please leave it in the comments below. Thanks for watching everyone, and I will see you in the next one. Bye bye.